That is all the handshake protocol. Let's have a look at it live. I will go back on the way I build the connection. That when I build the connection, reading from the inside to the outside, I first make a network process that connects to the node. I stored it in my struct Ouroboros network, and I pass it directly to the Ouroboros handshake function. You're wondering why I'm repeating Ouroboros everywhere. In Emacs, we don't have packet like namespaces, and everything resides on a global namespace. Thus, it is something you're forced to do always to avoid name collisions, to prefix all your functions and variables with the name of your package. That's rather annoying, but you get used to it. That means when I do call the function Ouroboros connect, I create all these things and directly go into the handshake. I will call this. So set q is to set a variable. I use connection. That was going to be my new variable. Ouroboros connect. And I have to give it a remote. The first argument is the remote, that is location of my socket. I have saved that in the Cardano txcli node socket. This is a variable containing the path of my socket, and the network magic. I'm going to connect to the Vasil DevNet. It has the network magic 9. And because this is Lisp, I can run and execute the code live in here. So I execute this, and it replies me with this object Ouroboros network. As you see right in the line right below, it has the process, 9 is the network magic, 13 is my version, and it's a node to client communication. Thus, it means it worked. I have established a communication to my node because I know I resolved after the handshake the version I am communicating, the protocol version. The next thing I want to show you is the local state query mini protocol. It has a state machine with a larger amount of steps and states. When I initiate my state machine, the first thing I do is to request through the message acquire for a point on the chain. And I wait for the server to reply to me with an answer. And the server will reply you with a failure. That point doesn't exist, or that point is too old for me to keep in memory. Or it will reply positively, yes, I acquired that point in the blockchain for you. And I enter in the state acquired. Once I am in that state, I query something and the node replies with the result. And after I have the result, I can refresh and ask for a new point, or I can just release and then close the connection with done. Again, all this is translated into a data structure, a transition table. Let's have a look at the communications. So in the specification, I have all this message: acquired, replied, acquired, failures, queries, results, release, reacquire, and done. They all have a CDDL representation. Let's see, for example, left at the code. You see the messages are defined in one big chunk, but the way we handle the software is in two parts. Is what I ask is down here, and what I receive is up here. For example, the reply acquired is, well, if my reply is the array 1, I say, yes, I acquired something. If I have failures, this is the array 2 and a failure. And what can be a failure? It's a 0 of a 1, point to old, point not in chain. I do the same. The array 2 and 0 is a failure, point to old. The array 2 and 1 is a failure, point not in chain. And likewise 4, and then whatever is afterward is the result. Is again the message result is an array for result. And when I'm asking or initiating the communication, well, the acquiring of the message is, if I want to acquire the tip, when I ask the queries, I have a message in arguments optionally. I want to acquire the tip, it's the 8, or a vector of 0 and the argument 0 and point. Point is a very specific way Cardano has of defining a block on the blockchain. I can do a query. Query is 3 and the query itself. When I want to release is the 5, reacquire. If the tip is the 9, otherwise it's 6 with a point. And when I want to close the state machine is a 7. That's it. I have just implemented the protocol. Now, the query is not specified on the specification, and I have gone over the trouble of figuring it out. So in my website, Ars Magna, where I keep my Cardano related project, I have the Ouroboros network local state query mini protocol. That's a summary of it. It gives you the reference of all the data you don't have on the network specification. So what is the point? It's either the origin or a block header hash. Block header hash is a slot number. And this int is actually the hash. It's a byte string there. I repeated the protocol messages, but I give you the queries. For example, the query system start is a query of an array 1. I just told you here the system start query, when it's the 1, that's the system start. This is how I handle the reply. I know it looks complicated, that's very dense. The block number, the chain point does 2 and 3. Block number is 2, chain point is 3. Let's have a look at how do I do these queries. I use the function Ouroboros local query. That's the function I have below. I give it the connection. That's the variable I just created on the handshake, which is my query. I want the system start. However, before I do that, as it is specified by the state machine of the protocol, I need to acquire a point on the chain before I can do a query. I want to acquire the tip. If I evaluate this, the reply is I acquired, it was fine, it all worked. And now that I have acquired, I can indeed ask for the query, and I want the system start. This is how it works on my system. And I receive, well, the Vasil DelphNet started on the 6th of June of 2022 at 14 p.m. UTC. I can do the exact same, but and send the as an argument the unparsed, unedited. And I'm asking the same. I received this array, the year, the day of the year, and the picoseconds. This is what I describe you in my website. The start is, again, an array of 3 things: the year, the day of the year, the picoseconds. If I do the same for block number, use this 2 and I get an array 1 block number. Let's do that. That's the block number. I could have also used my translated human readable path, which is the block number symbol. I get something more explicit. Let's ask for the era, right? This is this vector. I get the era 5. That is Babbage. And in my implementation, when I ask for current eras, I get a translated form, something I can work on my system. And that is pretty much it. As you see, I evaluate code live on my editor. That's why Emacs is, or programming in Lisp is so much more productive when prototyping things, as you get an immediate feedback of your work. And then you can always clean this up and send it to a test. I have to close the connection, of course. I want to release. And then I want to send a done message. And as you see at the bottom of the screen, I also received this process. The Ouroboros mini had the connection broken by the remote. I killed the state machine and the node just kills the connection as well. That is it. That's how you communicate with the node. Hope you have a lot of fun reading the specification, comparing it to my implementation. Learn something new about Lisp. Implement this in your favorite language. There are projects like Halas from TXPipe. They have implemented this in Rust. They have not implemented the local state query, but they are quite advanced on the chainsync protocol. But quite advanced. They are feature complete on that one. And I hope they also copy my implementation so that they have also the local state query on their system. There is the Shelley queries, which is a very extensive set of queries that I have also documented, where you get more information about the current state of the node. There is more complicated. There are some advanced queries for which I have no idea what comes back. For example, all these debug queries, they are just too big to parse. In the Vasil DelphNet, this is about 90 megabytes. In the testnet is about 600 megabytes. Those are things too big to parse for myself at this moment, but it will get done at some point. Please like the video, recommend it to your friends. I hope you learned something. I have some projects on Catalyst on extending some of my work. I would be happy if you help me with your vote, and I'm happy to receive feedback on this work and many of my other Cardano related works. Bye.